but I can't see from my, okay, all right. So this is VN diagram. You can see here on the vertical axis, this is the G load, and on the aircraft structure, and on the horizontal, this is speed. So anything you see orange and red, if you're operating in that region, for example, you're pulling 6G at the speed of 200 knots, and then the structure will be damaged. So gas, what happened to gas? If you aircraft being pushed, say you have a vertical airspeed and vertical velocity, vertical it's the air hitting you vertically because the gas is mostly vertical air. Then you have increased the speed. Then you operating beyond this envelope. Then you damage the structure. So I do not want to go into the detail of this. However, what I'm trying to say is one of the potential cause of the structure failure, structure damage, is turbulence. Next is the evasive maneuver. The aircraft may go into evasive maneuver in the case of near miss. There are another aircraft, they have to avoid the aircraft, and then they have to pull the aircraft, and sudden pull the aircraft increase the G. As the G increase again, if you go back and remember your VN diagram, you may already outside the envelope, and then the structure will be damaged. And third, it could be vibration. The vibration can caused by failure of component. If you have problem with the engine, you probably have ruptured the turbine disc, or you're losing the turbine blade. In fact, you maybe lost some part of the propeller, and then you will experience excessive vibration on the aircraft, and then that vibration may also cause damage on the structure. It happened when the 380 flew for the flight test for flutter testing, and when they reached to point Mach 92, they have found severe vibration, and then they abandoned the test. They stopped the test and flew back the aircraft to the base. Then they inspected the aircraft. They found there are chunk of the part in the area around the main landing gear has broken off. So that broken off has caused severe vibration. End up they had to stop the flutter test. Propeller engine failure, I have explained to you. Flutter is imbalance of mass in the structure. You may, and also in the aircraft, you may install modification with certain component installed on the aircraft, and that also can cause vibration and flutter on the wing. And you may also have repair on the wing, which cause also mass imbalance, especially when you repair the control surfaces. So the flutter is one of the cause can damage the aircraft structure. There are cases where because of flutter, the aircraft wing broken off. You see a video in YouTube, there is F-117 Stud Fighter has completely broke off the wing because of the flutter. And heavy landing, one of the common event because of the weather. Maybe you experience the aircraft experience wind shear as they get close to the ground. The wind shear, the wind change direction, that's what we call wind shear. The wind slam the aircraft into the ground, so that can cause heavy landing. Or the error in the maneuvering the aircraft. The aircraft may have to come fast and short or runway, so end up you slam the aircraft on the runway. That also can be heavy landing, so that also can cause major damage to the structure. Bird strike is another common problem because there are birds flying around. In fact, the aircraft structure has been designed to withstand around 7 pounds of birds, and still that is average birds. Sometimes the birds are bigger and there are many, and as they hit the aircraft, it can cause severe damage to the aircraft structure. And this is always happen. It happen frequently on the aircraft, and that's why there's also some equipment installed around the airport to prevent the birds to come into the airport area. Lightning strike is another common problem, as aircraft flying into the air, and they also may encounter weathers, and they also build up the static charges. They also been lightning. Lightning can hit aircraft anytime. There are systems to prevent the aircraft from being totally burned by the lightning. However, they still they still cause some damage, which is significant, which have to be repaired. Most of the lightning strike damage, at minimum, you can see they just like pitted, pinhole, something like someone punched the skin with a pin. So those are pitted damage. And also you can see discoloration on the skin. So discoloration means that already the skin has exposed to heat, and the area strength is reduced because the tempering condition of the material at the area has changed. They also damage on the ground where you have been operating the aircraft on the ground. There are many things come into the aircraft. There are cargoes, catering, refueling, pauser, tow bar, tow truck for aircraft which are not with aircraft landed at the airport with no gates. They also have movable stairs. Those are the potential costs of the damage to the structure, because all this equipment may hit the aircraft structure, which is quite a common problem for this truck hitting the aircraft. Environment, obviously, environment is something we can avoid because we are operating in the area we have moisture, and it's worse if you're operating near the sea because there is a moisture containing salt. So salt is good electrolyte, and obviously it will cause corrosion. So environmental cause corrosion damage. The material itself is susceptible to fatigue, like I have shown you earlier on the first week. Each material having has been tested, and they have shown the trend in the SN curve, which the material life will be shorter if they are exposed to high stresses. So mean they have been damaged during the high stresses, and those damage accumulated, and that can cause the structure to fail. They normally fail in terms of crack and fracture. And all those events will cause damage. I can see the table here. It's something I have promised you can look at it. However, this is just a summary. Turbulence, what kind of damage? Evasive maneuver, excessive vibration, propeller, engine, turbine failure, flutter, heavy landing, bird strike, lightning strike, aircraft operation, ground, truck and movable stairs, environment, material. So you can see here what is the damage on the right here. Turbulence, for example, you may have structure crack, some aircraft bend. There are cases where the aircraft, I think China Airlines many years ago, they dropped into, I think they dropped to 15,000 feet, and when they landed, the whole aircraft fuselage bent, bow. Deformation, that is deformation. Rivets failure, you can see rivets heads missing, rivets pull out, distortion, buckle, wrinkle. Evasive maneuver, you may also have the same kind of structure damage, and we call all this they call it structure overload. Vibration normally cause crack, propeller, engine, turbine failure. The debris will hit the structure, cause puncture. The flutter cause vibration, also end up with a crack. Heavy landing could be similar to the structure overload, where you experience in turbulence and evasive maneuver. Bird strike is punctured because the bird goes into the aircraft, and I've been doing repair on L-100, which is a US military aircraft. The flaps is punctured through the bird's wing into the flap and settle inside the flap. So it's very difficult to repair because we have to clean up all those birds things first before we can derivate the structure and install a new skin plus some doublers. So it's very messy if you have bird strike. Lightning strike is a burn fitting on the skin, heat damage. So there is a discoloration. So lightning cause heat, and the heat cause structure to fail. So it's just like you burn the structure. Aircraft operation on the ground, puncture, cracks, crash, gouges from those trucks, from those movable stairs. Environment corrosion, there are many types of corrosion, exfoliation, pitting corrosion, and etc. There are many types of corrosion. Material fatigue is fracture and crack. So those are the potential cause or the damage and the type of damage occurred in the aircraft throughout their operation cycle. Question. Okay, next, damage assessment. All this structure have to be assessed for damage. There are reports you may receive the structure has been damaged. There are reports where you already have complete damage report. There are reports which do not have much detail, where you need to explore further. There are also damage which is only superficial, but you need to go into the inspection, in detail inspection, to determine the extent of the damage. So there are many scenarios. So most of the time, if you got heavy structure damage, you have to bring the aircraft into the hangar, and you have to prepare the aircraft for detailed structure inspection. The photo shows C-130 Hercules major damage. This aircraft has hit a hangar, and you can see the nose has damage, and also part of the wing has been ripped off. I was working on this aircraft when I was with Aero. So what we need to do when we have damaged the aircraft, you have to bring the aircraft to the hangar. You have to jack up the aircraft to be level. You have to put them on the permanent trestle. Trestle is the support of the structure, and you need to bring the aircraft to as level, as relaxed as possible. Mean there are no area in the of the aircraft structure has been stressed. It's a relaxed condition, no loads on it except on the trestle and on the jacking. Because why? Because we need to see the natural condition of the aircraft structure for us to be able to determine the detail, the real extent of the damage on the structure. Otherwise, if the structure is not in the relaxed condition, in the free condition, you may not be able to see the detailed damage. When you do damage mapping, so it is very simple exercise. What normally that we do, we go to the aircraft IPC, we make a copy, several pages of the IPC, you go to the aircraft, start to take note. When you see the damage, you just put the note there, the area where it has been damaged. and also explain what kind of damage that you see at the time. Also, at the same time, we also need to see whether the damage is permanent, especially when the aircraft has been reported experience heavy landing or experience turbulence. We want to see whether the aircraft is distorted or the aircraft still remain in good condition. Because distortion is permanent deformation and that is not allowed in the aircraft structure, so we do alignment and symmetry check. There are drawings published by the OEM of the alignment and symmetry checkpoint for the purpose of this inspection. That is the inspection to see generally the condition of the aircraft, whether there has been permanently distorted or still or the aircraft still in the condition as per it was delivered from the factory, so it's still good. So we use alignment symmetry check to determine the status of the aircraft after having that major event, and which also having badly damaged due to the event. Then once you have completed those damage mapping and damage investigation, we will classify the damage but we have to refer to OEM structure repair manual, and we classify the damage as major damage, minor damage, repairable damage, beyond repair. Those are based on the information given in the structure repair manual. The structure repair manual has given will give the detail of the condition or specific area of the structure when it has been damaged, whether it's repairable, not repairable, or consult OEM for repair. Those are the kind of option normally given in the structure repair manual, which we have to determine for each defect that we found, so we can easily make a projection of the potential repair required, what are the costs, and how long the aircraft will be in the hangar to be restored for the structure integrity to be restored. Then once we have all those information, we publish a damage report. A damage report which I have shown earlier is every one of these forms been raised for each defect that you found, and we compile them if there are many defects found. If you got found 5 defects, you can see wing spar broken, fuselage skin punctured, landing gear cracked. So each of the main event, you prepare this report and compile them. Then again, most importantly, when you are preparing the report, you should not miss this component: aircraft data, component data, inspection data, detail of damage, and what is the requirement, what is your requirement on the area. So because these defect reports may go to several places at OEM depending on the area of the structure. They are not like us where we have in the airline, we are technical services, 1 or 2% in the technical services of the airline, we work to cover everything. But for OEM, they are big, they have certain people to work on certain structure. They have that kind of the luxury to have the engineers to work on every part of the structure, every component, every area of the structure. And also they're receiving hundreds of this report every month from all the operators and owner of the aircraft around the world. Okay, and then again, you also have to do a sketch for the defect, and you have to show global view, you have to show local view, and then you write an email, a memo to the OEM to explain the detailed damage. Okay,